Hi dear students, today we are going to discuss a question that is written here. You can observe that if alpha and beta are the roots of, let me just mark the question so that you can understand, like if alpha and beta are the roots of a equation that is given by this function, or we can say that is given by this equation, quadratic equation, whose roots are, okay, equation. Then equation whose, sorry, if alpha and beta roots of this equation, the equation whose, okay. Then we have to find the equation of this root, okay. That means we have to find the equation whose roots are this, okay. These two values are given whose roots. So let's start to solve it. So let me just observe. Okay. Now let's continue. So first I am going to tell you some rule. As we have given, if we have a given equation of the form ax square plus bx plus ka c, okay, and as we have given alpha and beta, two roots of this equation, okay, this equation what we have above given, so they must satisfy the two properties, that the sum of root is equal to, if this is a b, so here we have minus ka b by a, okay, this is a, and the product of two root is given by c by a, that means c by a, okay. So this is a true formula what we have to use to find the equation for these two roots what we have given here. So let's move ahead. Before moving ahead, I will have to tell you that if I divides the whole equation by a, what we get? Here we get b by a, here we get c by a. So we can directly put place b, that means replace b by a by minus this by this terms, okay, and c by a by the alpha into beta terms, okay. So I'm going to use this concept. So let me first try the what we have roots are given. Roots given are 1 upon में a alpha plus ka b is the first root, and the second root is a beta plus ka b. These are the two roots. So as we have previously told you that if these are the two roots, so we suppose that, let suppose it satisfies, it means they satisfies, it means roots satisfy equation ax square plus ka bx plus ka c is equal to 0, okay. The satisfy means what? If we put these roots here, so we get 0, that means they are the root of this equation, okay. So I can write this equation in the form of a x square plus ka b by ax plus ka c by a, no doubt till here, okay, is equal to 0 or something like equation only if we are writing, we did not require to write here 0, okay. I'm taking only equation at this time, so I'm not writing, just wait, it's not working well, okay, 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 okay. So this equation can be written in the form of this also, and you can put here 0, no problem, okay. Now let's move ahead. So you can observe that if we sum these two roots, we get minus ka b by a. So b by a calculated from here. And if product these two roots, we get c by a. So I'm going to calculate these two values, and so that we can obtain our equation which is in the form of this. Okay, let's find it. So from this equation, what we have assumed to be the solution of, not solution, to be the equation for these two roots must satisfy these two property. Then the sum of two roots should be equal to this, and the product of two root is equal to this. So I'm going to use that. So we have the sum of two root is equal to minus ka b by a. So here we have minus ka b by a should be equal to 1 upon में first root was a alpha plus ka b plus ka 1 upon में a beta plus ka b, these two root. So let's add them. When we are adding them, we get a b plus ka b plus ka a alpha plus ka b. Division by, just multiply them, and what we get, just observe. Don't multiply, just write it this time, because I'm going to tell you something extra so that we can reduce our calculation, okay. So here we have this is minus का b by a. Okay. ठीक है. Then let's solve it. When we add these two terms, we can take a as the common. When we take a common, what we get? We get a times alpha times of beta plus का 2b upon में this terms, that is a alpha plus का b, and here we have a beta plus का b. And what is the value of a alpha plus beta? We can observe it from the first equation. Alpha plus beta was minus का b by a. Okay, minus का b by a. So okay, here we have this satisfies the minus का b by a. So in place of alpha plus beta, I can write minus का b by a. So just write it. So we get here minus का b by a plus का 2b upon में a alpha plus b, a beta plus b. So when you multiply, we get this get cancel out. So we have minus का b by a is equal to what? Here we have minus का b and here we have plus का 2b. So when we add, we get only b. So b upon में this whole term, that is nothing but the a alpha plus का b into में what we have a beta plus का b. Okay, this we get. Now let's move further. Before moving further, what we need to calculate? We need to calculate this time c by a. That is nothing but the product of these two roots. So first root is alpha plus b into second root was 1 upon a beta plus ka b. So just product them. So what we get? 1 upon, again these terms we get. That's why we have not calculated this previously, because I want to tell you that we have to calculate it twice, otherwise. Okay, now we will calculate the value that is in the denominator part. So let's calculate them. So okay, you can observe from here that this is the value of this. So what you observe from here? You can observe from here that I can replace the value of b by a and the value of c by a from here. When we multiply by both sides by minus, we get here minus here plus. Okay, so we calculated b by a value and here we have c by a value. So just put these two values in this equation, because this equation must be satisfied as per the property we have basically done, that is b square by a. I don't know what's happening. So okay, so I'm going to put in this equation the values what we have calculated. So we obtained x square plus ka b by a should be what? B by a should be minus ka b times of this. So just write it. So we get minus ka b by. Okay, just wait. I think we have done something. We have done something wrong. Doing something wrong. No. Here we have plus ka 2b and 0. So okay, no, nothing is wrong. Okay, let's find it. So here we have minus ka b by what? Minus ka b by a alpha plus b. And the second part was a alpha plus b and a beta plus b. X times, because here we have x minus b by a was multiplied with x, and here we have c by a. Okay, so just in place of c by a, where the value is this value. So as you can observe, this denominator part is common in both. So if I add 1 to the value what we have obtained here, is nothing wrong. So I'm adding 1 only. Okay, because this part is included in the 1 by c, b by c by a form. That's why I'm putting this is equal to 0 must be satisfied. Is equal to 0, no problem till here. So now just solve them. When you solve them, this is y1. So we take LCM. After we take LCM, we get what? We get here a alpha plus ka b, a beta plus ka b, minus ka bx plus ka 1 is equal to 0. Because denominator will get multiplied to 0, so we get 0 here. After taking LCM, okay? No problem. So let's move further. So what we get? Just multiply them. What we get? A square times of a. Either you can take this in this way, or you can take common a from this term. When you take a common from this first part, we get alpha times of b by a. When you take a common again from here, what we get? Beta times of b plus a. This time I'm just calculating these two values, then I will put the value of this. I'm going to calculate the values of this only, right, this time. And here we have also x square. I just forget to write it, because when we take LCM, this part will be multiplied to this, so x square should remain here. Okay, no problem. So when we get a common from here, we get this part. So you can observe from here, what is the value of b by a? It was in our first page. This was minus b by a. So when we take b by a value, so they both get negative. So I'm putting them into negative form. So I can write here a times of alpha minus ka beta. You can observe this by how we get these values by the value of b by a, and again into my a times of, again with the value of this will be the minus ka a alpha minus ka beta. So when you add, what we get, this here we get alpha is cancelled, here we get beta is cancelled. So you multiply the values, what we get. You can observe that 1a 2a, that means they will when we multiply them, we get a square times of, here we have minus ka b, and here we have plus minus ka alpha, and minus ka beta minus ka alpha. So we get alpha into beta, because minus into minus will get plus. What was the value of alpha into beta? Just observe from the first equation. This was c by a. So put in place of alpha beta c by a. Place of alpha beta c by a. So we get a square into c by a. This is our what? This is our the coefficient of this part. Let me just mark it. The coefficient of this part is what we are calculating below. Okay, so the value of this will be, the value of this will be what? This should be equal to 1a will cancel out from this part, so we have remaining is ac only. So I'm going to put the coefficient this onto the place of these values. Okay, so just put it. So what we get? We get ac x square minus ka bx plus ka 1 is equal to 0. This is the equation what we obtain after just evaluating this value. You can observe from here. Okay, so what we get at last? We get that what equation we have solved that satisfies these two roots. Okay, as that satisfies these two roots, so that equation what we required, or we can say what we have supposed at the starting of the solution, that equation is obtained to be the this equation, sorry, this equation. Now let's check in our options of the given question, is it given in that option or not. So let's observe. Okay, so you can observe that this equation. Okay, let me just change my markers. Okay, you can observe that second option is similar. Okay, ac x square minus ka bx plus ka 1 is equal to 0. So our second option is correct. Okay, you get it or not? You can just check it back. Okay, that's all for today. Have a good day. Bye bye.